All right, that was one skills number 30, factoring a squared minus b squared. So the a squared minus b squared pattern is just a plus b times a minus b. Okay, you take the square root of each, basically, and you add and subtract the two. Now, if you were to multiply this out, you'll see why it's a squared minus b squared. There's a cancellation in the middle there. But it's best to recognize this pattern. Perfect square minus perfect square. You have to have a minus in the middle for it to work. And notice there's only two terms. It's not a trinomial pattern. So you're not looking to add two numbers together and multiply something else. You're just taking the square root here. So a few examples. X squared minus 9. So notice the pattern. You have this minus. There's only two terms. And this is a perfect square. Anything that's to an even power is going to be a perfect square. And you've recognized from simplifying square roots that 9 is a perfect square. We just take the square root of both. The square root of x squared is x. The square root of 9 is 3. So it's x plus 3 times x minus 3, and that's it. It doesn't matter if you put the minus or the plus first. Second example, a little bit more complicated, but you have the same combination. You have a binomial with a minus in between. Take the square root of both. So the square root of 4 is 2. The square root of 25 is 5. So this ends up being 2x plus 5 and 2x minus 5. 2x times 2x is 4x squared. 5 times negative 5 is negative 25. Of course, you have these middle two terms also if you're multiplying, but they cancel. A third example, and you could put multiple variables in there, and I didn't put anything that went to the fourth power here. You could have even powers, but I don't know that you'll see any of those in Algebra 1. 16x squared minus 49y squared. Same idea. You got a perfect square minus a perfect square. So notice the pattern. 4 times 4 is 16. We need the x with that. 7 times 7 is 49. We need the y with that. All right, so this is factoring the difference of two perfect squares.